All right, let's do P6. Let me go find it. Oh, I think that's why I did that. I changed the order so it makes more sense. Yeah. Never mind. P6 will be later. Yeah, I rearranged it so it'd be easier because factoring should be right before quadratic equations, so I just forgot. So now we're moving on to complex numbers. So basically, in a nutshell, right? If you square root a negative number, you see this negative a, an I comes out. I is the imaginary piece, which makes it a complex number. So if you were to square root -4, you would get 2i. Is essentially the way it works, but a real number. So the complex number, picture it as like a bigger set of numbers that also contains the real numbers. So a real number will be considered inside complex. Okay. So now number 7, this right here is the complex number. Okay. A plus bi is 9 plus 2i. So the 9 and 2 are the real number components, but the entire thing itself together, the entire piece is the complex number. Okay. Now, excuse me. Let's do some of the operations. Let's go to number 10. This was 1.5 complex numbers. Sorry, I'm trying to feel groggy today. Number 10. 7 plus square root of -25. So remember the rule, the square root of -1 is equal to I, or square root of -a is equal to square root a and then the I to the side. Let me switch back. Okay, so basically, the way you can think about it is that you have a -1 times the 25. So this would be -1 times 25. Square root of 25 is 5. Square root of -1 is I. So you get 5i. That makes sense? You always put the I at the end. You could put it in front, but it's weird. Okay. Let's do another one. This one doesn't square root perfectly, but all the ideas of radicals when we were reducing, you remember the beginning, will be important here. So this will be -1 times 12. So separate it into -1 times square root 12. But I don't know why I put that. This becomes 1 minus square root. Remember, we want to find squared numbers. So break it up into 4 times 3. The I, square root of -1 would just be the I, so put it at the end. So this becomes 2 square root 3 I. Is there any questions on this example? Do you remember the simplification for radicals? All right, 1 second. Let me find the next one. Yeah. Let me give you a nice image here. Just kind of cool pictures. So back in the day, when we talked about real numbers, rational numbers, right? Natural numbers are numbers starting from, well, it depends on which book, but usually after 0, the counting numbers are 0 through infinity, right? 0, 1, 2, 3, 4, 5. You keep going forever. Whole numbers, you know what? I don't like that picture anymore. Here we go. Natural numbers are inside the integers. Integers are inside the irrational. Irrational are separate. They're different from rational. Rational are all the fractions, and all integers or positive and negative whole numbers, right, can be written as fractions. Both of these, though, are inside the real numbers. So every number that we deal with is a real number. Things that are imaginary are over here, but complex combines everything into one giant set. Okay. So going back to the homework, right? The way you write it, in case you didn't watch the theory, a plus bi is the general form of the complex number. A and b are real numbers, but this is just a general complex number. Okay, let's look at 13. 13, we need some rules to help us out. So when you raise the i's to different powers, there's different results. So remember that I to the first is equal to just I. I to the second is equal to -1. I cubed is equal to -I. I to the fourth is equal to 1. So these will repeat. Okay. Over and over. So if I keep going to 5, it will be this first one. And don't forget that I squared is equal to -1. I'm sorry, I wrote that. We're good. We're fine. So in this first example here, 13, it says, what is -6i plus I squared? So that'll be -6i plus a -1. And there's nothing else I can do. Although they usually write the number first and then the complex part, right? That's pretty much it though. I should say as powers increase. Assuming they're integers, of course. All right. Yes, cool on 11 and 13. Any questions on this? Does it make sense? Okay. After that, after those types of questions, you'll see basic operations. Like 15. It says perform the operation. In this case, they want us to add. You got 2 plus I plus 5 plus 3i. 2 plus 5 plus I plus 3i. So just get the ones that are numbers together because they're just pluses. This is a weird looking 5. So 2 plus 5, I plus 3i. That'll be 7 plus 4i. So treat it like terms. Put the i's together, numbers together. Any questions on 15? Sixteen is the same thing. It's just minus. So make sure you're cool with your signs. So -5 plus I. That'll be 6 plus 5 is 11. I minus I is 0. So technically you could write that and be weird, but it's just 11. Any questions on these two? The addition and subtraction. All right. Okay. Over here, 17, you first simplify the radicals and then do the same thing we did up here with number 15. So there's not much difference. Just like combining the first few questions in the homework to number 15. Over here, same stuff. It's just you move things around, watch your signs, combine like terms. Basically, like we're adding X's and Y's or whatever. Who cares? You guys have any questions on 17 or 18? All right. Let's do one of the products. Let's do 19. Four minus 2i. Okay, there we go. All right, so just multiply it. Basic multiplication, like FOIL or box or whatever. So 6 times these guys minus 5i times those same things. Then distribute 6 times 4, 6 times 2, negative 5 times that, negative 5 times this. But here you get the I squared. So this is where things get a little different. 5 times 2, I times I gives me this, right? So you got to be very careful with your signs here. So 24. 12 minus 20, that'll be minus 32i plus I squared is a negative 1, right? So we get 24 minus 10 minus 32i. So 14 minus 32i. Is there any steps that don't make sense? Okay, so not too bad, right? Yeah, just be careful when you get a power on the I. Remember the I rules, okay? You'll be good. Number 21. Here are two conjugates, right? 3 plus square root 5i times 3 minus square root 5i. So that'll be 3 squared minus this squared. That'll be 9 minus 25i squared, which is 9 minus 25 times negative 1. So 9 plus 25. Oops. Excuse me. You guys remember the difference of squares, right? The conjugate pairs. Okay. All right. Let's see. Let me show you the homework again. Towards the end, they want you to put the quotient in standard form, meaning they do not want any I stuff at the bottom. See how they have got some I's. So it's just like rationalizing. You remember when you had a square root down there? You would multiply by a conjugate to get rid of it. So same approach, except you're using the I instead of a square root. All right. Let's do, I don't know, 25, I guess. Let me write down the question and I'll switch over. Write the quotient in standard form. So multiply by the conjugate. So that'll be 2 times 5 plus 9i over this conjugate here would give you the difference of squares, right? So at this point, you get 10 plus 18i over 25 minus 36i squared. So this is 25 minus 36 times -1. So that becomes 10 plus 18i over 25 plus 36. No more i's. We're good. 25 plus 36. What is that? 4161. Is that right? Pretty much it. Anyway, is there any question on this section? Is it all right? Is it strange? Is it easy? Okay. That's pretty much it for 1-5. That's fair, Victoria. All right, so exam 1 is going to be over would be P2, P3, P4, 1.4, 1.5. There is a practice test in a reference sheet. I need to change the dates on this. It's a little too soon. Let me see. I would like you to have it done by next Monday, but if life happens, you have until the 28th, okay? Try to do the review without notes just to see if you can do it. But here are the answers for it. Number one, use prime factorization to reduce. So I want you to break it down completely into prime numbers and then cancel your terms. So 132, what is half of, they're both even, so we could do that. Half of 132, what is that going to be? Let me switch back over. $66, right? Let me double check. Yeah. So 2 times 66, this will be 2 times 170. Break this up further, it'll be 2 times 6 times 11 over 2 times 7 times 10. So all the prime numbers would be 2 times 2 times 3 times 11 over 2 times 2 times 5 times 7. So here are all the prime numbers. So cancel the like terms. After that, it is completely reduced because we can see it, right? We can see there is nothing else in common. Any questions on what I expect on number one? Or something similar? All right, number two. simplify the following. So basically you want to get, you want to add all the fractions. We can go ahead and square this guy though. That'll be 4/9. So the LCD will be 3. Well, to find the LCD, you first got to factor all the denominators. So 3 is 3. 6 is 2 times 3. 9 is 3 times 3. So LCD will be, start with the smallest number. 2 only appears once in any given location. So 1, 2. 3 appears once, twice. So the most number of times it appeared in one spot is twice. There's no other factors. So LCD will be 2 times 9. So change all these into 18. Okay, so in order to change this, I need to multiply by 2/2, multiply by 3/3, that'll be 8/18 minus 6/18 plus, forgot to multiply this guy. Now, I'm assuming you remember your fractions, and if not, let me know if something doesn't make sense. So add these up, that'll be minus 16/18. So 8 minus 16 will be negative 8/18. Okay, so reduce, that'll be, we'll leave the negative in front because it doesn't matter. 2 times 2 times 2, prime factors of 8. Prime factors of 18 will be 2 times 3 times 3. So only 2 cancel. So our answer is 4/9. Any questions on number 2? All right, I'm not turning the page then. Number 3. Simplify. We've done a bunch of these already. You did some today. Look for squared numbers that go into 96. What goes into 96? Not 9. 16 does. Cool. You want to choose the biggest squared number that goes in. So square root of 16. And you get 4√6. So completely reduced and simplified. Any questions on number 3? Okay. Rationalize the denominator. -3 over square root 5. Well, that's 4. Rationalize. You have to multiply by the conjugate, kind of like we did the imaginary numbers. Same process. So that'll get us -3 times this conjugate thing over a squared minus b squared. Distribute the -3. This becomes 5 minus 16, which is 9, right? No, it's not 9. What? Yeah, shoot. It's not feeling myself today. Okay, well, that's it. That negative at the bottom is kind of weird. So it's to just multiply the negative up top. So it's like you're dividing by negative on every turn, but not the 11. Yeah, thanks, Megan. That'll be 3 root 5 minus 12. So you could do that if you want. Any question on rationalizing? Oh, did I? Oh, yeah. It's after the fraction. So let's read and label these. This is 4 and 5. I skipped 3. Thanks, Trevor. Let's do 3 here. So rules of exponents. Then I gotta give you a bunch of them. Okay. So raising this to the 5 means you're going to raise each single piece to the 5th power, 5. So that'll be, what you could do is just do every little factor and put a 5 on it. Let's raise each one to the 5th. I'm not messing with the bottom yet, but there it is. So 3 to the 5th, I don't know what the heck that is. Oh, wait. No, yeah, we're good. 3 to the 5th, what is that? Monstrosity. Seven. I'm gonna Google this one. You guys, don't judge me. 3 to the 5th. Yeah, that's right. Okay. 243. X to the 3rd to the 5th means you multiply the powers. Multiply the powers. So we get 243 x to the 15 y 10 over 9xy squared. Ouch. Okay. 2243 divided by 9 is 27. X15 divided by x is x14. So let me show the work. When you divide the same power, right, you subtract. So 15 minus 1, 10 minus 2. So I'm dividing the x's and the y's and the number. So our answer will be this. Is there any questions on any of the steps here? I'm going to skip these unless you want to see them. Are you comfortable? Anyone have questions on this multiplication here for number 6 and 7? These two. All right, I'm gonna skip the next one unless someone has a question. 8, 6, 7, 8, 9. This one's pretty basic too, but let's go ahead and do this one. Factor GCF. Oops. GCF of 6x squared plus 9x. So factor out 3x, you'll get 6x squared. Oops. 3x is the biggest that go is the biggest factor that goes into both, right? Let me switch back. So GCF is the greatest common factor. So factor it out, and you will get 2x plus 3. Number 10. So here we do factor by grouping. Number 10. Get take two at a time and find out what is GCF for the first two and last two. These both have 3x in common, so factor that out and you get 2x plus 7. These both have a what? 4? This becomes 2x plus 7. Factor out 2x plus 7, you end up with 3x plus 4. And that's it. You guys cool on 9 and 10? So first thing you should always do is factor the GCF. You also want the biggest power to be positive. So I'm going to factor a negative 4x from the entire thing, leaving me with x squared minus x minus 2. So now my A and C are 1 times negative 2. This is negative 2. So the only factors of negative 2 that add up to negative 1 is going to be 1, negative 1, 2, and 1. So this 4x is not going to do anything, just ignore it. Now I will use a bracket. So we're going to have x. Well, they said to use AC method, so hold up. So this becomes plus, now let's use minus 2 plus 1 minus 2. Now you do grouping. Factor x from these first two terms. Getting you x minus 2, factor, well, there's nothing in common, so 1. So we get negative 4x times x minus 2 times x plus 1. Are there any questions on how we did AC method on this guy? I know technically we didn't have to do it because this was kind of easy to deal with. But since they said AC, we did it. If it doesn't say what method to use, then use whatever method you want. Okay. You guys cool with 11? All right, let's move on to 12 or 13, I guess. Actually, let's go ahead and take a short break here. Let's take a 10-minute break. We'll start up again at 7:20. Okay. So to solve a quadratic, we said we need to set it to 0, step 1. So subtract the 15 over, and then use a method of your choice. Here they didn't tell us what to use, so use whatever you want. I'm going to use AC method. So A times C is negative 30. So that will be factors of negative 30 that add up to this. Does that happen, actually? There's negative 2 and 15. 2 and negative 15, but that adds up to 13, negative 13. Oh, yeah, shoot. Forgot about. No, what the hell's wrong with me? 3 and 10, obviously. 7, negative 7. There it is. Yeah, no problem, Steven. All right, so factor the 10, or so you're going to break the negative 7 into negative 10 plus 3x. Now do grouping. Factor 2x from the first two. Factor 3. Then pull out the x minus 15 or x minus 5. So set this equal to 0, this to 0. Solve for x. I skipped the algebra steps. Do you have any questions on how we solve for x here? And zero factor property is setting each piece. Once it's factored, you set them to 0. Solve for x.
Would it be negative 3 over 2?
Okay. Let's move on then. Next question is still solve a quadratic. Solve a quadratic equation using the square root property. So when you have, yeah, it should be a minus there. Screw both sides. But as soon as you do, you tack on the plus or minus. Now, just subtract the 5 over and you're good. So negative 5 plus or minus square root of 14. Okay. So the next method says use completing the square. So I'm assuming you guys are cool on 14. Okay, factor a 2 out of every term. You can divide it out so we don't have to worry about it. So at this point, just complete the square. So I need to add to both sides a special number. I might as well just move the 3 over. It's going to happen regardless. And that special number will be half of b squared. And our b is 25. 10 divided by 2. 10 is b, divided by 2 is 5 squared. So this will now be a perfect square. Minus 5 minus 5. So x minus 5 squared is equal to 28. Square root both sides, and we're pretty much done. So this becomes x minus 5 equal to plus or minus 4 times 7, which will become plus or minus 2 root 7. So x is equal to 5 plus or minus 2 root 7. Any questions on completing the square or square rooting? Well, when I completed the square, I had to add 25 to both sides. And I added the 3 over just because it was going to happen regardless. So 3 plus 25 gives me the 28. This is a completed square, so it factored. And then I square rooted both sides, but it's already a 28 here. All right, we'll do one last one. I'm going to skip the last few because we just talked about complex numbers. Unless you have a question, of course. But the next one is quadratic formula. I feel like that was a while ago. Okay, so set it to 0. That's the first thing you should do. Move everything to the left-hand side. So A is 1, B is -2, C is 5. Remember that the standard form is written like this. X is equal to -b plus or minus b squared minus 4ac over 2a. You plug it all in and you get -2 there you go. That'll be 4 plus, I'm sorry, minus minus is +2. It gives me 4 minus 20. Looks like we're gonna get a complex number, I think. Double check my work here. B squared is 4 minus 4ac, negative, negative. Yeah, okay. Oh, well. So that becomes 2 plus or minus square root of -16 over 2. This becomes 2 plus or minus 4i, which reduces to 1 plus or minus 2i. Any questions on number 16? Okay. The last few we just talked about. Here you multiply complex numbers. Here you distribute one, same thing, multiplying. Here you not rationalize, but you get rid of the I on the bottom. We did one of those recently. Here you deal with I to the 4th, which is going to be equal to 1. Remember I gave you those rules? So break it up into pieces so you can see it. Because I squared is -1, so that's I squared times I squared, which is -1 times -1, obviously +1. Any questions on the review or concerns? All right, guys, well, we'll stop here. You guys have any questions about homework or